Hi everyone, and welcome to the fourth video of BIOB20. In this video we're going to discover a new kind of random variables that are called continuous. So far we have seen only discrete random variables, like the binomial distribution for instance, which we can sample with the function OR_binom. For instance, this is the way that we generate a sample with 10 random binomial numbers with parameters n equals 384 and p equals 0.5. The results that we obtain are called discrete. They are integer numbers like 0, 1, 2, etc. We have also seen the Poisson distribution, which we can resample with the function OR_Poiss. For instance, this is the way that we generate 10 random Poisson numbers with the parameter lambda equals 385. And again, the numbers that we obtain are discrete. But some random variables are continuous. And one example of continuous random variable is the uniform distribution. We can sample from the uniform distribution with the function OR_UNIF. By setting n equals 10, we get 10 random numbers from the uniform distribution. You can see that the numbers are no longer integers, they are float numbers between 0 and 1. To check the shape of the uniform distribution, we can increase the size of the sample a little bit and wrap it inside the hist function to see the histogram. When we do this, we obtain a histogram where all the numbers that we get seem to have approximately the same frequency. If we further increase the size of the sample, we see that the histogram becomes even flatter. This averages out the fluctuations due to random sampling. You can also see that we never obtain a value that is below 0 or above 1. In summary, every number between 0 and 1 has exactly the same chance of appearing in the sample. Next, we are going to see a new method to select elements from a vector. To have something to work with, let us create a sample of size 5 from the uniform distribution. I can store the results in a variable x and display the values in x on the screen. We have seen before that we can select the elements of x by their index. For instance, x^1 returns the first element. Likewise, x^2 returns the second element, and so on. We have also seen that we can use vectors instead of numbers. For instance, if I say x^C5, 2, I get first the element of x at position 5 and then the element of x at position 2. There is yet another way where we use the values true and false to specify whether we want to include or exclude the values. For instance, if we only want the first element, we would pass true, false, 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 false. If we want the first and the fourth, we would pass true, false, false, true, false. Note that with this method, there is no way to invert the elements like we did with 5 and 2 in the example before. We can get the same result with the expression x^C1, 4, and in this case, we can invert the numbers with the expression x^C4, 1. So what is the advantage of this notation? The answer is that we can combine it with logical operations. For instance, we can request which values in x are greater than or equal to 0.5, and we see true for the indexes where this is the case. Now we have a vector of true and false, and we can use it for selection. With this method, I can get the elements of x that are greater than or equal to 0.5, not just where they are, but what they are. The same applies to any kind of logical operation. If we reverse the inequality, we get the 3 elements that we did not get before. This method of selection is really handy because we can select from any vector with any condition that we like. Next, we're going to see how to extend the functionalities of R. Many functions are available in so-called libraries. But before a library is installed in your computer, it is called a package. So to download and install a new library, we need to use the function install.packages. Today we're going to install a package that is called Circular. You then get a long list of servers to download from, also known as mayors, and we're going to pick the one in Ontario. In this case, we download the content from the University of Waterloo. It appears in red, but this is not an error. This is just an information. You get some additional information, but the only thing that matters is that the package has been installed properly. It is now a library. We can now load it with the function library. Note that we do not need the quotes anymore. When you do this, you get the warning that the functions sd and var no longer refer to the stats package, but to the circular package. Everything is saved on disk. This means that if you close your OR session and open it again, you will still have access to the library circular. You need to do this only once per session at the moment you start OR. This library will come in very handy when we want to represent points on a circle. We are going to demonstrate this on a uniform random sample of size 100. But instead of selecting the numbers between 0 and 1, we are going to select them from 0 to 2 pi. And I do this by setting max equals 2 times pi. If we directly call the function plot on x, we get something that is not very interesting. The numbers are in a random order and they go from 0 to 6.28. The package Circular will allow us to plot this in a more interesting way. Instead of plot x, we say plot circular x, meaning the function circular from the package Circular. Now you can see that the points are nicely laid out on a circle, and the value of x corresponds to the angle on that circle. Next, we're going to see an improved version of R, which is called RStudio. Go to your favorite search engine, look for Install RStudio, and make sure that you head over to the site that appears on screen. It is called Download the RStudio IDE. This brings you to a site where you can choose the version of RStudio you want to download, and you will pick the free version. Make sure that you pick the RStudio desktop and not the RStudio server. Download it and follow the instructions for your operating system. When RStudio is installed, start it and you should see an interface like this one. On the left you have the OR session, and on the right you have some new panels that will become quite handy. This is not a different OR. This is the same OR as before with a different display. One way to demonstrate this is to try Library Circular, the package we have just installed. You will see that it is available even though we have never installed it for RStudio. RStudio is more friendly than R because it has a feature called Instant Help. This means that you see contextual help while you are typing the commands. For instance, if you type OR unif n equals 10, max, a little panel appears on the right. The panel shows some information that is taken from the help page of the function OR unif. If we finish the call with any value, like 2 times pi, we can see that the results look exactly like in R. If we store the results in a vector x, we can now see a slightly different behavior. The variable x has been added in the right panel called environment. Even though the values of x have not yet been printed on screen, you can see that they are already available in the environment panel. Another difference is the behavior of the plot function. With the same command as before, plot circular x, we can see that the plot appears in the bottom right panel. In general, everything is a little bit more friendly with RStudio, so feel free to use it instead of R. That's it for today. Good luck with the quiz, and see you in class.